Good evening everyone, I am Mr. Amrit Khanna from Faculty of Civil Engineering, University of Wollongong, and today I am here to give my presentation on my research topic, that is the analysis and design of the foundation. Let's introduce our topic, that is the foundation. Foundation is defined as the lower part of the superstructure that transfers the load of the structure to the overlying material, and generally we consider the soil or the ground as the overlying structure. Next, significance of the topic. Today, it is the age of the engineering or the constructions. Every day, new and new constructions are being made. It varies from simple storage building to the high-rise building, and from simple roads to the deep bridges. And every constructions need a strong base for their durability and the sustainability. That's why the topic, that is the analysis and design of the foundation, is considered the significant one for these aspects. Functions of the foundations. There are several functions of the foundations. First of all, it reduces the load intensity of the structure and distributes those intensities equally on the soil. Second, it provides the level surface for the constructions of any structures. Besides this, it provides the lateral stability, it protects the structures against the soil movements, and finally, the foundation provides the safety against the undermining effect of the water. Next, geotechnical properties. Geotechnical properties of soil are also an important aspects to be considered or studied in the foundation engineering. Before the analysis of the foundations, these things or the properties of soil are to be analyzed, and among these, soil classification. ASTO has classified the soil in 3 different categories depending upon the sieve size, that is the size of the particles ranging from 75 mm to 2 mm, it is classified as the sand, and the particles less than 2 mm is classified as the silt, and finally the particles less than the 0.02 mm is classified as the clay. And the second one is weight volume relationship. The weight volume relationship is also an important aspect to be analyzed. The soil is made up of 3-phase system, that is the soil particles, air and water, and in this relationship void ratio is to be determined at the first. And what we consider void ratio is the ratio of the volume of the voids to the volume of the soil particles for a given mass of the soil. And third comes the Atterberg limit. The Atterberg limit, it consists of the 3 different type of the limit, that is the plasticity limit, liquidity limits, and the shrinkage limit, and hydraulic conductivity. These property of the soil are most significant in the constructions of the dam or the structures in the water. Hydraulic conductivity means the amount of the water passing through the soil mass per unit time. And stress can be defined as the sum of the effective stress and the pore water pressure. The stress helps to determine the property of the soil to resist the load from the structure. Compaction and the consolidation. The degree of the compaction and the consolidation are also to be determined, as these factors play a significant role in the settlement, or they may give the deflection for the foundation. That's why the degree of compaction and consolidation are also to be determined. Settlements of the foundation. Here 3 figures, that is the first one with the no settlement, second one with the total settlement, and the third one is with the differential settlement. Here we can see in the figure the third one, or the differential settlement, is considered as the most serious or the risky factor whenever we encounter a small deflection or the little deflection, then it can be considered in engineering works. Let's come to the different types of the foundation. Generally, there are the 2 types of the foundation, that is the shallow and deep. We consider the foundation as the deep when the depth of the basement is greater than the width of the foundation, and vice versa. That is here the general difference between the deep and shallow foundation can be illustrated by the picture. Now let's come to the shallow foundations. Whenever we encountered several situations for the shallow foundations, when shallow foundation is adopted when the underlying soil is strong enough to hold the pressure or the load of the structure. Second, when we we adopt the shallow foundations when the load of the structure is the moderate. When we identify the weak soil on the shallow depth, then the mat footing is generally used. Here are the different types of the shallow foundation, that is the strip footing, spread, combined, strap, and the mat footing. And these figures generalize the concept of the different types of the footings for the shallow foundations. The first one is strap, isolated, combined, strap, and the mat footings. Let's come to the second types of the foundation, that is the deep foundations. We categorize the deep foundations on two different topics, that is based on the load transfer, based on the materials, and based on the mode of the installation. First one, based on the load transfer, we can categorize the deep piles into the three categories, that is the in or point bearing piles, friction piles, and the common of both friction and the in bearing piles. Based on the materials, there are the various materials used in the constructions of the piles. Generally, we can see timber, steel, concrete, or the combination of each of these materials. And the third one is based on the method of the installation. There are two different modes of the installation, that is the board or the replacement, and driven and the displacement. We can generalize the concept of the board edge. We first of all, in this board installation, we make a pit, bring a pile there and install it. And for the driven ones, we drive the piles directly into the ground wherever it is needed. And here are some figures that illustrates the different types of the deep foundations: the steel edge pile, steel pipe pile, precast concrete pile, wood pile. And obviously, most of us are seeing this one wherever we go. Foundation constructions. I have tried to submit some of the construction procedures through these figures only. The first one is spread footing, this one the large spread footing, and the third one driven piles, and this one is the mat footing. Next, and the general view of the driven piles. In these two pictures, we can see how the piles are driven into the side. And obviously, we might have seen these two vehicles in most of the engineering works. They are nothing but I just included in the topic because they are also a significant part, because they are used everywhere. The first one is the backway, and second one is the dozers. Soil improvement techniques. It is also one of the significant topic that I have included in my research. Generally, the techniques, different type of soils are identified in the site, and for this should be improved if they have the weak strength. And we can use three different modes, that is bypass the soil and use the deep foundations, and in other case we can remove the soil and use the engineering field. And finally, we can improve the properties of the soil by various methods. Concerns. Here the topic says that what we need to consider in the soil improvement techniques. There are various factors to be considered for this. The first one is type of the soil in the site. We need to know whether the soil is clay, sand, or the silt, and the properties of the soil, that is their stress, strength, and comparability. Besides this, depth and area of the treatment. This also play a major role in the soil improvement techniques. We need to know the depth of the treatment where we are going to carry, and the area of the treatment. Fourth one, structure supposed to be constructed. This is the major factor. We need to identify the structure above the soil, that is the load that the foundation will be carrying. That soil, the soil is to be treated according to the load to be carried, and availability of manpower, equipment, and the skills. This point clearly identifies that we can improve the soil based on availability of manpower, equipment, and skills. And finally, and the most important one, is the economics. Economics play a significant role. If we have a greater economics or high cost, then we can go through the different stages of the soil improvement. And here are the list of some improvement techniques. The first one, soil mixing and use of the chemicals. Soil mixing and use of the chemicals clearly defines that mixing of two different type of the soils or the use of the chemicals in the soils for the to increase the strength of the soils. The second one is compaction grouting. Here the soil mass is compacted by using a heavy weight. It is repeatedly lifted up and drop down on the ground to increase the compaction. Deep densification. This method is generally used to increase the or densify the density of the soil. Most commonly there are two different methods in this one: vibrocompaction and deep dynamic compaction. Stone columns. Stone columns are also constructed in the site where there is a possibility of the soil movements. Besides this, soil reinforcement and geosynthetics is also one of the methods. Soil reinforcement, it clearly defines that use of the tensile materials in the soil to increase its stability, and geosynthetics means the use of the geotextiles or geogrids in the field to increase the stability of the soil. Preloading and the ground freezing. Preloading is the application of some external or more force on the compressive soil so as to increase the strength of the soil. And ground freezing, obviously this point determines the technique used in the high water content. We use different chemicals or different methods to freeze the water content inside the soil. Then the water converts into the ice, the stability increases, and it acts as like a glue or something, and the soil becomes hard. And finally, here are some of the methods of soil improvement techniques that I tried to introduce in some figures. The first one, grouting. Here the grouting process, the grouting is injected through the machines. The second one, compactions. The stiff wheels of the dozers are used to compact the soil. Next, and the preloading, as I have already discussed, application of some external vertical stresses here, and vibro replacement stone columns. These are the columns constructed on the site to increase the stability of the soil. And finally, soil reinforcement and the geogrids. Look, through the use of the various tensile stresses, we are increasing the stability of the steep ground slope. And here the geogrids, the workers are spreading the geogrids over the ground to increase its stability. And finally, I have done my research with following references. I have tried to collect more and more information through these ones, and here my presentation ends. And thanks for everybody, and thank you.